if 2x plus y plus a is a focal chord of the parabola y square plus 8x equals to 0, then a equals to, require the value of a. Now, the parabola y square equals to 8x, or 8x taken right side, y square equals to minus 8x, its axis opposite side or negative x axis. The equation of the parabola y square equals to minus 8x. Now, its axis is a negative x axis. Its focus equals to minus 2 comma 0. Focus equals to minus a comma 0 or minus 2 comma 0. Now, it is a focal chord. Any chord passing through focus is called focal chord. Any chord passing through focus is called focal chord. Equation of focal chord given 2x plus y plus a equals to 0. Now, the point minus 2 comma 0 lies on the chord. Now, substituting the point minus 2 comma 0 in the equation, minus 4 plus 0 plus a equals to 0, then a equals to 4. The value of a equals to 4, then second option. PQ is a double ordinate of the parabola y square equals to 4x. Of the parabola y square equals to 4x. The locus of points of trisection is the locus of points of trisection. Now, x axis, y axis, the parabola. If suppose parabola equation, consider y square equals to 4ax, standard equation of the parabola, but actually given y square equals to 4x, yet the value of a equals to 1. Value of a equals to 1. Now, the double ordinate, consider AB is one double ordinate. AB is one double ordinate, because a chord of the parabola perpendicular to axis is called double ordinate. Required the locus of points of trisection. Points of trisection. If suppose the chord AB divide into 3 equal parts such that these 3 are equal, then required locus of points of trisection. Points of trisection. Now, let the coordinates of the point A 80 square comma 280. The coordinates of the point, consider 80 square comma 280. Now, the coordinates of the point B, it is nothing but image of A with respect to the x axis. Now, coordinates of the point B 80 square comma minus 280. 80 square comma minus 280. Now, trisection points divides the line segment AB in the ratio 1:2 or 2:1. 1:2, 1 point, second point, 2 parts is to 1 part. Now, this point we get x coordinate on this line always same, 80 square comma 280 by 3. Now, required locus of the point 80 square comma 280 by 3. Now, 80 square comma 280 by 3 is one of the trisection point. Now, required locus of this point, locus of the point. Now, here x equals to 80 square, y equals to 280 by 3. From these two equations eliminate to t, we get the required locus. Now, from second equation, the value of t equals to 3y by 2a. 3y by 2a. Now, that value substitute in the first equation, x equals to a into 9y square by 4a square. 1a cancel. Now, 9y square equals to 4ax is the locus of trisection point. Now, it is also a parabola, its vertex is also same. If suppose the number of double ordinates, take the trisection points. Now, join all the trisection points, we get another parabola. Its vertex same as vertex of the given parabola. Now, 9y square equals to 4ax, but in given parabola a equals to 1, a equals to 1, substituting the required answer 9y square equals to 4x. 9y square equals to 4x. Fourth option. the equation of tangent to the parabola y square equals to 8ax, y square equals to 8ax at 2a comma 4a, at 2a comma 4a. Now required equation of the tangent to the parabola y square equals to 8ax at 2a comma 4a. Now equation of the tangent nothing but s1 equals to 0. Now y1 equals to 4a into x plus x1, but x1 y1 is the given point. Y into 4a equals to 4a into x plus 2a. 4a get cancelled. Now y equals to x plus 2a is the required tangent. Now from options, if suppose y is taken right side, x minus y plus 2a equals to 0. X minus y plus 2a equals to 0, third option. The equation of the tangent to the parabola y square equals to 8x, y square equals to 8x inclined at 30 degrees, inclined at 30 degrees with x axis. If suppose x axis, y axis, the given parabola y square equals to 8x. Required tangent, equation of the tangent which inclined an angle 30 degrees with x axis, 30 degrees to the x axis. Now a straight line inclined an angle theta with x axis, then its slope equals to tan theta, m equals to tan theta, but theta equals to given 30 degrees, tan 30 degrees value 1 by root 3. Now slope of the tangent equals to 1 by root 3. If slope of the tangent is m, then equation of the tangent y equals to mx plus a by m. The equation of the tangent in the slope form y equals to mx plus a by m. Now y equals to the value of m 1 by root 3 into x plus from parabola equation 4a equals to 8, a equals to 2, a equals to 2. Now a by m 2 by 1 by root 3, or y equals to 1 by root 3 into x plus 2 root 3. By taking LCM and cross multiplying, root 3y equals to x plus 6, or for implies x minus root 3y plus 6 equals to 0 is the required equation of the tangent which inclined an angle 30 degrees with x axis. Now option is fourth option. The equation of the normal to the curve x square equals to 4y, x square equals to 4y at 1 comma 2, at 1 comma 2. Now equation of the parabola given x square equals to 4y and point 1 comma 2, 1 comma 2. First differentiate the equation with respect to x. Now 2x equals to 4 into dy by dx, for implies dy by dx equals to x by 2. Now dy by dx at a given point 1 comma 2 equals to 1 by 2. It is nothing but slope of the tangent, slope of the tangent, but required equation of the normal, equation of the normal. Now slope of the normal equals to slope of the normal equals to minus 1 by slope of the tangent, or that equals to minus 2, minus 2. Now it is considered m. Now slope of the normal equals to minus 2, but normal passing through the point 1 comma 2. Now slope point form of the straight line we get. Now y minus y1 equals to m into x minus x1, but point x1 y1 1 comma 2, m equals to minus 2. Now y minus 2 equals to minus 2 into x minus 1. Further simplifying, we get 2x plus y minus 4 equals to 0. The required equation of the normal at a given point 1 comma 2 to the given parabola x square equals to 4y is 2x plus y minus 4 equals to 0. Second option. the equation of the tangent to the parabola y square equals to 8x, y square equals to 8x, which is parallel to the line x minus y plus 3 equals to 0. Now, the required tangent to the given parabola parallel to the line x minus y plus 3 equals to 0. Now, slope of the given line equals to 1. Slope of the given line m equals to 1. Now, tangent equation in the slope form y equals to mx plus a by m. Y equals to mx plus a by m. Now, y equals to, at the value of m equals to 1, x plus 4a equals to 8, then a equals to 2. Now, y equals to x plus 2 or x minus y plus 2 equals to 0 with the required equation of the tangent which is parallel to the given line. First option. The straight line x plus y equals to k, x plus y equals to k touches the parabola y equals to x minus x square, y equals to x minus x square if k equals to. Now, the straight line and curve touch each other. If suppose the given curve or parabola and straight line touch each other. Now, required point of contact, first the value of k. The given line is the tangent to the given parabola, required the value of k. Now, always any curve and straight line intersect at 2 points, but a curve and a straight line touch each other, then the common point is only 1. Now, the straight line equation and curve equation having only one common point. Now, eliminating y from two equations, k minus x equals to x minus x square. Now, x square minus 2x plus k equals to 0. Now, the curve and straight line having only one root or common roots, then the quadratic equation roots must be equal. The roots of the quadratic equation must be equal. Now, b square minus 4ac equals to 0. B square minus 4ac equals to 0. B square nothing but 4 minus 4 into a1 ck equals to 0. Now, k equals to 1. 4k equals to 4, k equals to 1. Third option. Next, the line y equals to 2x plus k, y equals to 2x plus k is a normal to the parabola y square equals to 4x, y square equals to 4x, then k equals to, require the value of k. If suppose y equals to mx plus c, the line y equals to mx plus c, parabola equation, standard equation y square equals to 4ax. Now, the line y equals to mx plus c is a normal to the parabola y square equals to 4ax, then the condition c equals to minus 2am minus am cube, c equals to minus 2am minus am cube. Here the value of c equals to k equals to minus 2 into a equals to 4a equals to 4, a equals to 1, m equals to 2 minus 1 into 2 cube. Now, k equals to minus 4 minus 8, that equals to minus 12. Now, the value of k equals to minus 12. Second option is the correct. The point of contact of 2x minus y plus 2, 2x minus y plus 2 to the parabola y square equals to 16x, y square equals to 16x. Now, the given line y equals to 2x plus 2, it is a tangent to the parabola y square equals to 16x, y square equals to 16x. Now, here m equals to 2, because the line in the form of y equals mx plus c, c equals to also 2. Now point of contact in terms of only C and M. C and M is C by M comma 2C. The point of contact. Contact in terms of C and M. C by M comma 2C. Not necessarily the value of A. Now C by M 2 by 2 comma 2C 4. Now that equals to 1 comma 4. The point of contact is 1 comma 4. Third option. The equation of the common tangent to the circle x square plus y square equals to 2a square and the parabola y square equals to 8ax. Required equations of the common tangents to the circle and parabola. Now, the center of the circle is origin. The circle equation x square plus y square equals to 2a square. Vertex of the parabola is also origin. The parabola equation y square equals to 80x. Now, we get two tangents, two common tangents. Required equations of that common tangents. Required equations of the common tangents. If suppose consider slope of the tangent equals to m. Slope of common tangent equals to m. Slope of common tangent m. Now, equation of the tangent to the parabola with slope m. Equation of the tangent to the parabola with slope m is y equals to mx plus here the value of a equals to 2a. 2a by m. Now, y equals to mx plus 2a by m is always tangent to the parabola y square equals to 80ax. Y square equals to 80x in the slope form, but it is also tangent to the given circle. Then perpendicular distance from center of the circle to the line must be equals to radius of the circle. Perpendicular distance from center 0 comma 0 to the line equals to radius of the circle. Now perpendicular distance from origin to this line 2a by m by square root of 1 plus m square, but that equals to radius of the circle root 2a. Now a cancel, cross multiply and squaring on both sides, 4 by m square equals to 2 into 1 plus m square. Now 2 times cancel, again cross multiply, m power 4 plus m square minus 2 equals to 0. Now by solving this equation, or m power 4 plus 2m square minus m square minus 2 equals to 0, or m square common in first two terms, m square plus 2 minus 1 common, m square plus 2. Now m square equals to 1 or minus 2, but m square not negative, then second option, or m square equals to minus 2 invalid. Now m square equals to 1, m equals to plus or minus 1, m equals to plus or minus 1, substitute in the equation of the tangent y equals to mx plus 2a by m, then we get common tangents equations y equals to plus or minus of x plus 2a, y equals to plus or minus of x plus 2a, then second option is the correct. The equation to the line touching the parabola y square equals to 4x and x square equals to minus 32y. Y square equals to 4x and x square equals to minus 32y. If suppose the parabola equations y square equals to 4ax and x square equals to 4by, required equation of the common tangent to the parabolas y square equals to 4ax and x square equals to 4by. If suppose x axis, y axis, first parabola y square equals to 4ax, y square equals to 4ax. Similarly, the second parabola x square equals to 4by. Now required equation of the common tangent for both the parabolas. Equation of the common tangent for both the parabolas. Now slope of the tangent to the parabola x square equals to 4by, consider m, then its equation in the form of x equals to my plus b by m. Equation of the tangent to the parabola x square equals to 4by must be in the form of x equals to my plus b by m. But it is also tangent to the parabola y square equals to 4ax. It is also tangent to the first parabola y square equals to 4ax. Now this equation converted in the form of y equals mx plus c. Now my equals to x minus b by m, or y equals to 1 by m into x minus b by m square. Now y equals to 1 by m into x minus b by m square. Now it is also tangent to the parabola y square equals to 4ax. It is also tangent to the parabola y square equals to 4ax. Then c equals to a by m. Now here c nothing but minus b by m square. Minus b by m square equals to a by 1 by m. Now for implies m cube equals to minus b by a, or m equals to minus b by a whole to the power of 1 by 3, or cube root of minus b by a, cube root of minus b by a. Now the value of m equals to minus b by a, substituting in the equation x equals to my plus b by m, we get the common tangent equation a power 1 by 3 into x plus b power 1 by 3 into y plus ab whole power 2 by 3 equals to 0. The equation of the common tangent to the parabolas y square equals to 4ax and x square equals to 4by is a power 1 by 3 into x plus b power 1 by 3 into y plus ab whole power 2 by 3 equals to 0. Now that the value of a equals to, in the given parabola, a equals to 4a equals to 4, a equals to 1, 1 power 1 by 3 is 1 into x, 4b equals to minus 32, now b equals to minus 8, minus 8 whole to the power of 1 by 3 equals to minus 2, now minus 2y plus ab whole power 2 by 3, now plus 1 into minus 8 whole power 2 by 3. Now here even exponent, that equals to x minus 2y plus 4 equals to 0. The required common tangent equation x minus 2y plus 4 equals to 0, fourth option. The sum of slopes of the tangents to the parabola y square equals to 8x, to the parabola y square equals to 8x, drawn from the point minus 2 comma 3, drawn from the point minus 2 comma 3. Now the given point lies outside of the parabola. If suppose parabola equation, consider y square equals to 4ax, standard form, the given point px1 y1 consider, or any point, it lies outside of the parabola. From external point, two tangents can be drawn. Now required sum of slopes of these tangents, sum of slopes of the tangents. Now let m be the slope of one of the tangent, m is slope of one of the tangent. Now equation of the tangent to the parabola y square equals to 4ax in the slope form, y equals to mx plus a by m, but it passes through px1 y1. Now y1 equals to mx1 plus a by m. By taking LCM as m, we get x1 m square minus y1 m plus a equals to 0. Now it is a quadratic equation in terms of m, it having two roots. That roots consider m1 and m2. Now sum of slopes equals to y1 by x1. Sum of slopes or sum of roots of this equation equals to y1 by x1. Similarly, product of roots or product of slopes equals to a by x1. Now sum of slopes equals to y coordinate of given point by x coordinate of given point. Now that equals to minus 3 by 2. Minus 3 by 2, third option. the point of intersection of tangents at ends of the lattice rectum of the parabola y square equals to 4x. The point of intersection of the tangents at ends of the lattice rectum of the parabola. If suppose parabola equation, consider y square equals to 4x or standard equation. L dash is lattice rectum. Now, at ends of the lattice rectum, tangents are drawn to the parabola. Required point of intersection of tangents. Now, ends of the lattice rectum a comma 2a and a comma minus 2a. A comma 2a is one end of the lattice rectum, a comma minus 2a second end of the lattice rectum. Now, first equation of the tangent to the parabola y square equals to 4x at a comma 2a is s1 equals to 0. S1 equals to 0. Now, y1 equals to 2a into x plus x1. Now, here x1, y1 nothing but a plus 2a. Now, y into 2a equals to 2a into x plus a. Now, 2a get cancelled, y equals to x plus a. It is equation of one tangent at one end of the lattice rectum. Similarly, at end of the second lattice rectum is y equals to minus of x plus a. It is second tangent or at the end of the lattice rectum. Now, by solving these two equations, we get, now from first equation subtracting second, we get x plus a equals to 0 or x equals to minus a. Now, x equals to minus a substituting y equals to 0. Now, minus a comma 0. Now, it is nothing but foot of the directrix. Z minus a comma 0 is foot of the directrix. Now, at ends of the lattice rectum, tangents are drawn to the parabola. They intersect at foot of the directrix. Now, also these tangents perpendicular to each other. Means the tangents at ends of the lattice rectum perpendicular to each other and they intersect at foot of the directrix. Now, foot of the directrix minus a comma 0, but actually in a given parabola 4a equals to 4, a equals to 1, then required point minus 1 comma 0. Third option. The locus of point of intersection of perpendicular tangents to the parabola y square equals to 4ax. The locus of point of intersection of the perpendicular tangents to the parabola y square equals to 4ax. Now, parabola y square equals to 4ax. Two tangents perpendicular to each other. Consider p x1 y1 with the point of intersection of perpendicular tangents. Now, required locus of the point p x1 y1. Now, if suppose slope of one tangent is m1, slope of the second tangent m2, but two tangents are perpendicular to each other, product of slopes equals to minus 1. m1 m2 equals to minus 1. But product of slopes of the pair of tangents drawn from x1 y1 to the parabola y square equals to 4ax is a by x1. Now, minus x1 equals to a or x1 plus a equals to 0. Locus of x1 y1 is x plus a equals to 0. Means always perpendicular tangents intersect on the directrix. Or the locus of point of intersection of perpendicular tangents is the directrix of the parabola. Its equation x plus a equals to 0. Second option. The locus of point of intersection of two tangents to the parabola y square equals to 4ax, which makes angles theta 1 and theta 2. with the axis such that tan theta 1 into tan theta 2 equals to k. Tan theta 1 into tan theta 2 equals to k. Now parabola y square equals to 4ax. Axis of the parabola is x axis. Axis of the parabola x axis. Now tangents. Makes angles theta 1 and theta 2 with its axis. Required locus of point of intersection of these tangents. Consider P x1 y1 with the point of intersection of tangents. Now one tangent makes an angle theta 1 with x axis, second tangent makes an angle theta 2 with x axis. Now slopes equals to slopes of the tangents tan theta 1 and tan theta 2. Slope of one tangent is tan theta 1, slope of the second tangent tan theta 2. Now given condition tan theta 1 into tan theta 2 equals to k, tan theta 1 into tan theta 2 equals to k. Otherwise the product of slopes of the tangents equals to k, but the product of slopes of the tangents equals to a by x1 equals to k. Then locus of x1 y1 is kx equals to a, or kx minus a equals to 0. Kx minus a equals to 0. Second option. The number of tangents to the parabola y square equals to 4x through 9, 6. Now the given parabola, consider s equals to y square minus 4x equals to 0. Now substitute the point in the equation of the parabola s11 equals to 6 whole square minus 4 into 9, that equals to 36 minus 36 is 0. Therefore the given point lies on the parabola. The given point lies on the parabola. A point lies on the parabola. At that point we get only one tangent. Now number of tangents equals to 1. Second option. The chord of contact of 2, 1 with respect to the parabola x square equals to y. Now the equation of the parabola s equals to x square minus y equals to 0. Equation of chord of contact. Equation of chord of contact is s1 equals to 0. Now s1 equals to xx1 minus half into y plus y1 equals to 0. But given point x1 y1 is 2, 1. Given point 2, 1. Substituting in the equation we get 2x minus half into y plus 1 equals to 0. By taking LCM as 2, we get 4x minus y minus 1 equals to 0. The required equation of chord of contact 4x minus y minus 1 equals to 0. Fourth option. The polar of the point 5, minus 6 with respect to the circle x square equals to 8y. Now consider the given equation of the parabola s equals to x square minus 8y equals to 0. Now the polar of the point is also s1 equals to 0. Polar of the point s1 equals to 0. Chord of contact s1 equals to 0. Polar equation s1 equals to 0. Equation of tangent also s1 equals to 0. Now s1 equals to xx1 minus 4 into y plus y1 equals to 0. But point x1 y1 is 5, minus x. Substituting 5x minus 4 into y minus 6 equals to 0. Further simplifying, we get 5x minus 4y plus 24 equals to 0. Now the required answer is 5x minus 4y plus 24 equals to 0. Fourth option. The pole of the line 2x plus 3y minus 4 equals to 0 with respect to the parabola y square equals to 4x, y square equals to 4x. If suppose the line equation Lx plus My plus n equals to 0, parabola equation y square equals to 4ax or standard equation. Now the pole of the line Lx plus My plus n equals to 0 with respect to the parabola is n by L comma minus 2a m by L, n by L comma minus 2a m by L. Now in given equation L equals to 2, m equals to 3, n equals to minus 4, a equals to, here 4a equals to 4, a equals to 1. Substituting in the formula n by L minus 4 by 2 comma minus 2 into a equals to 1, m equals to 3 by L 2. Now that equals to minus 2 comma minus 3. Require the pole of the given line with respect to the given parabola is minus 2 comma minus 3. Now second option. If the points 2 comma minus 1, 5 comma k are conjugate with respect to the parabola x square equals to 8y, then k equals to, now the given equation of the parabola, consider s equals to 0 or s equals to x square minus 8y equals to 0. Now two points are conjugate points. If suppose the points x1 y1 and x2 y2, now 2 points are conjugate points with respect to the parabola s equals to 0, then condition is s12 equals to 0, but s12 nothing but x1 x2 minus 4 into y1 plus y2 equals to 0. Now substitute the given points in the equation s12 equals to 0, x1 x2 10 minus 4 into y1 plus y2 minus 1 plus k equals to 0. Now 10 equals to 4 into minus 1 plus k or 5 by 2 equals to minus 1 plus k, then k equals to 7 by 2. The value of k equals to 7 by 2, second option. If the lines kx plus 3y plus 2 equals to 0, comma 3x minus 2y plus 9 equals to 0, are conjugate with respect to the parabola y square equals to 4x, then k equals to. If suppose the two lines, one is L1x plus M1y plus N1 equals to 0, second line L2x plus M2y plus N2 equals to 0. Now these two lines are conjugate with respect to the standard parabola y square equals to 4ax, then condition is L1 N2 plus L2 N1 equals to 2a M1 M2. L1 N2 plus L2 N1 equals to 2a M1 M2 is the condition. Now substituting the values of L1 M1 N1, L2 M2 N2 and a in this condition, now L1 N2 9k plus L2 N1 6 equals to 2a, here 4a equals to 4, a equals to 1, 2a equals to 2 into M1 M2 3 into minus 2. Now 9k plus 6 equals to minus 12, 9k equals to minus 18, then k equals to minus 2. The value of k equals to minus 2, fourth option. If the polar of the point P with respect to the circle x square plus y square equals to a square, with respect to the circle x square plus y square equals a square, touch the parabola y square equals to 4ax, y square equals to 4ax. Then the locus of the point P. Suppose consider P x1 y1. P x1 y1 is any point in the required locus. Now the polar of the point P with respect to the circle is s1 equals to 0. For implies we get xx1 plus yy1 minus a square equals to 0. xx1 plus yy1 minus a square equals to 0 is equation of polar of P x1 y1 with respect to the circle x square plus y square equals a square. But it touches the parabola y square equals to 4ax. It touches the parabola y square equals to 4ax. If suppose a line Lx plus My plus n equals to 0 touches the parabola y square equals to 4ax, then the condition ln equals to am square. Direct formula ln equals to am square. Now substitute in the formula ln x1 minus a square, x1 into minus a square equals to am square, a into m square, y1 square. Now 1a cancel. Now y1 square plus ax1 equals to 0. Then locus of x1 y1 is y square plus ax equals to 0. Locus of p x1 y1 is y square plus ax equals to 0. Second option. The midpoint of the line joining common points of the line 2x minus 3y plus 8 equals to 0 and the parabola y square equals to 8x. Y square equals to 8x. Now, suppose the given parabola y square equals to 8x and equation of the chord given 2x minus 3y plus 8 equals to 0. 2x minus 3y plus 8 equals to 0. Consider AB is a chord. Given equation of the chord and parabola equation. Required midpoint of the chord. Midpoint of the chord. Let P be the midpoint of the chord AB. Let P be the midpoint of the chord AB. Now consider A x1 y1, B x2 y2 are coordinates of the points A and B. x1 y1 and x2 y2 are coordinates of the point A and B. Now the midpoint of AB is x1 plus x2 by 2 comma y1 plus y2 by 2. Now by using the equation of the chord and equation of the parabola, eliminate x or y, any one of them, or form a quadratic equation in terms of x or y. Now y square equals to 8x, but from equation of the straight line or equation of the chord 2x equals to 3y minus 8. Substitute at that place 4 into 3y minus 8. Now y square minus 12y plus 32 equals to 0. Y square minus 12y plus 32 equals to 0. Now it is a quadratic equation in terms of y. Now it having two roots. The roots are y1 and y2. Y1 and y2. But here required only y1 plus y2 by 2, not separate values of y1 and y2. Now sum of roots of this equation equals to minus b by a, that equals to 12. Now y1 plus y2 by 2 equals to 6. Now y coordinate of the point P is 6. Y coordinate of the point P 6. Now the value of y equals to 6, substitute in the equation of the line. The value of y equals to 6, substitute in the equation of the line. Now 2x minus 18 plus 8 equals to 0. Now 2x equals to 10, for implies x equals to 5. Now midpoint of the chord is 5 comma 6. 5 comma 6. Now second option. The locus of midpoints of chords of the parabola y square equals to 4ax. The locus of midpoints of focal chords of the parabola y square equals to 4ax. Now parabola y square equals to 4ax. S is the focus. Now a chord passing through focus, it is called focal chord. Required the locus of midpoints of the all these chords, but passing through focus a comma 0. Focus a comma 0. Now first to consider px1 y1 is midpoint of the chord. Now equation of the chord is s1 equals to s11. Equation of the chord having midpoint px1 y1 is s1 equals to s11. Now s1 equals to y1 minus 2a into x plus x1 equals to s11 y1 minus 4a x1. But it passes through focus because it is a focal chord. Passing through focus a comma 0. Passing through focus a comma 0. Now at place of x equals to a, y equals to 0 substitute. 0 equals 0 minus 2a into a plus x1 equals to y1 square minus 4a x1. Now further simplifying, minus 2a square minus 2a x1 equals to y1 square minus 4a x1. Now complete terms take right side, we get y1 square minus 2a x1 plus 2a square equals to 0, or y1 square minus 2a into x minus a equals to 0. Then locus of x1 y1 is y square equals to 2a into x minus a. Y square equals to 2a into x minus a. Now second option.